Okay, perfect. Well, I think with that, we'll go ahead and get started. Thank you all for joining in our RCN webinar series today. We're fortunate to have Carrie Morrill and Chris Guiterman representing the WDS World Data Service for Paleoclimatology out of NOAA. And they'll be talking today about fair data practices and integrative software initiatives. And so without further ado, I will pass it to Carrie and Chris. Thanks so much.
Well, thank you. So I'm going to get the presentation going here. Um, cool. Does that look all right to everybody?
Yeah, it looks great.
You can see it. Okay. So I'm Carrie Morrill, and Chris and I will be presenting today on our work at the World Data Service for Paleoclimatology, and specifically kind of what we do that's fair and our vision for the future to make our data more fair. But first, I wanted to give a brief introduction to our team. I think we have a couple of team members also on this call. So I am the federal lead and the only civil servant on the team. Chris and Ed Gilly are our series, which is the Cooperative Institute for Research in Environmental Sciences. It's a cooperative institute that manages a partnership between the NOAA and the University of Colorado at Boulder. So we're really fortunate to have this kind of mixed team. Our series folks do a lot of work on the data management as well on the research side of things, which kind of allows us to build this research to operations sort of pipeline where series develops products, new processes, and then NOAA kind of puts them into operational practice. So in addition to Chris and Ed, we also work with two software developers who each spend half of their work time with us. They manage our database and do web development for us. So I'm going to start at the beginning here, where NOAA's paleoclimatology program began. So our team was established in 1990 at then NOAA's National Geophysical Data Center. And we were established in response to the Global Change Research Act of 1990, which Congress passed in order to have NOAA and other federal agencies combine and interpret data related to global change. So our first data sets consisted of 12 different contributions from tree rings, ocean sediments, space cores, climate reconstructions, and climate forcing, which is actually pretty kind of similar to what our scope is still today, with the addition of a couple new data types that have been added through the years. And at the time, this was kind of the dawn of data sharing. So the program funded data cooperatives and provided people money to organize, assemble, and document data sets for public sharing. And then 2 years later, we became the World Data Center for Paleoclimatology. This image here on the right is how we communicated with the community, this was kind of before email. So it was newsletters that got sent out quarterly. So what did FAIR look like in the early 1990s? I wanted to point out kind of how our operations worked, because there's a lot of legacy historical reasons why we do things the way we do. Sometimes it kind of goes back to the 1990s and how we got started. It may not make a lot of sense now, today, why we do things the way we do, but this is why. So in the early 1990s, folks found data sets by looking at these paleoclimate data sets order forms that were sent out in the mail. You could see at this time there were 13 data sets you could choose from. So that was findability. You just looked at the list and chose the ones you wanted. But each one cost. So you had to prepay your order, provide funds in US dollars, and mail them to our team. And the data sets would be sent via mail on floppy diskettes. So a couple years later, we moved to FTP. And our FTP directory structure is still what we use today in terms of how we organize data sets. It might seem somewhat antiquated, but again, this is a legacy holdover from how we used to do things. And as I've said, there are legacy impacts from these kind of old, or even sometimes the lack of standards in 1990 when we first got going. So this is where we are today. We're the World Data Service for Paleoclimatology. We steward 18 high-level data types, and they're shown here on this grid on the right. I have highlighted in pink the ones that we're most actively stewarding. For example, fauna, plant macrofossils, pollen. This might be a little known fact, but Neotoma, the data sets that are currently at Neotoma originally were archived with the World Data Center for Paleoclimatology. And then in 2005, moved to what then became the Neotoma Data Service. So we're not quite as active in those data types anymore. We steward more than 13,000 data collections, and each data collection is kind of a contribution that's sent to us from an investigator. And it often consists of multiple data files, sometimes multiple sites. And these collections come from more than 17,000 sites. And that's what this map shows on the lower right. In these data collections, we stored more than 500,000 individual time series, and we have accepted data from almost 9,000 contributors. Within our larger collection, we have two specialized collections, which are the International Tree Ring Data Bank, which are tree ring width, density, and other sorts of measurements, and the International Multi-Proxy Paleofire Database, which has two components. One is fire scars, measured from tree rings, and then the other is charcoal from lake sediments. We are Cortra Seal certified. We went through our last recertification process in 2025, and this just means that we documented all of the different ways in which we're fair, and it was reviewed by an outside board and we're certified as a trustworthy repository, and we're also a member of the World Data System. So just to dive in just a little bit more into the types of data we steward, as I mentioned, we have these two specialized collections, our International Tree Ring Data Bank and the International Multi-Proxy Paleofire Database, which are listed here on the left, tree ring and fire history. So these are primarily dendrochronological, with about 20 different measurement types. They have specific formats and standards, which have persisted for decades. In some cases, the Tucson decadal format for the tree ring data and the fire history exchange format for our fire scars. And both the data and metadata are quality controlled through various programs. The COFACHA for the ITRDB and BURN-R, of which Chris is one of the developers for the fire scar data. And I point this out because these data collections are perhaps more what you would be used to if you're a Neotoma user. It's like a research database. It's kind of very clean. The files are can be built together to kind of create a nice cohesive database. Whereas here on the right-hand side is everything else we archive, which is very heterogeneous. There's more than about 1,200 different measurement types. Our data files are kept in the flexible NOAA template format, which is a text format that contains metadata and then a data table. And our metadata is quality controlled, but less so the data itself. And this pie chart just kind of shows the broad distribution. The numbers are the number of data collections or contributions we've received from each of these very varied data types. And here I think I'm going to pass it to Chris to pick up.
Yeah, thanks, Carrie. Hi, everybody. Thanks for being here. Yeah, I'm Chris Guiterman, and just to pick up from where Carrie left me off here, so we have data stewardship. It's kind of one side of our work. The other is data product development. So this is where sort of Carrie and myself, being more physical scientists, come into play and help to use some of these data sets that we archive in developing products. So this also helps advance NOAA's mission, to further understanding in environmental and climate data and change, and to share out data. So one of the ideals with these products is that it makes it easier for really anybody to access and understand, versus something that's just really, particular to the research world. And we also conduct use-inspired research. So we try to collaborate with managers and other data users, that like environmental ecosystem managers, uh, to provide research information. Two of the most recent products we've developed are the Living Blended Drought Atlas. That's kind of what's flashing in front of you, the gridded colors. This is based on the North American Drought Atlas, which is a tree ring reconstruction of Palmer Drought Severity Index, which drought. It's been converted here to the climate.gov or the drought.gov sort of drought risk levels. And we're flashing through some various years because we wanted to kind of show how that time series corresponds to the other product that we're developing called the Gridded Fire History Atlas. So that's taking tree ring derived, annually dated fire scars, um, and just superposing them on top of the climate data. So you can kind of see the connection between drought and fire until anything with about a 1900 date on it, and then the fires go away across North America. So these products are or will be available on drought.gov. The graded fire history is not quite there yet. As I said, we're still developing it, but we have been using it in other research. So I have two references here from recent papers that are coming out using that fire product. Oh, next slide. I can't click. Thanks, Carrie. So maybe different than some other databases and data archives, certainly within the National Centers for Environmental Information, NCEI, which is where we sit within NOAA. We work a lot with the providers of data as opposed to kind of automatically procuring data sets from, satellites or other instrumentation. So there's a lot of interaction between our team and scientists that are creating the data. We have, instructions and templates and things like that to help them submit their data sets in a way that we can ingest them easily, but there's always some back and forth between our now single data manager. We used to have more, but and those scientists. So that's who is doing the curation and the quality control. We also harvest data from Neotoma and PANGAEA, so major, paleoenvironmental data sets. So we're kind of acting as a backup for them. All of that goes into our database that sits at NCEI that's composed of um, the metadata, so that'll be in the JSON or ISO metadata standards, and then the data sets, which is on the FTP as Carrie described. So we take all of that and we try to make it as accessible as possible to our users. So not only researchers, but also public folks that we'll talk about a little bit more, but kind of anybody in the world. We want to make this as accessible as possible. So we have, web maps and different search capacity for consumers to access the data. Slide. Thank you. So our contributions have been growing very steadily, in fact, increasing over time. Starting in the 90s, it was kind of bumping along. And then as we develop new um, data sets, particularly with really expanding the tree ring archives, and we received all of these borehole data sets as well. So that kind of created this jump in the total count in the early 2000s. But then since then, we've been growing at about 6% per year. So we have a doubling rate every 12 years. So it's fairly fast. Even though our staffing has gone down, our contributions are going up every year. And thanks to some technology and smart coding, we've been able to keep up with that and stay ahead of it. You can see on the right is different data types, none of which come in constantly. They often have kind of jumps to them, but there are a couple here that are growing very fast in the last couple of years, particularly in the fire history realm and the cave realm. Um, Caves, I think, is growing largely due to new technologies and new ways of quantifying the isotopes in the caves. The fire history has been favored by a couple different synthesis efforts. One is ongoing now, and as those move along, big jumps of data are coming in from those synthesis efforts. So representing, sites that were collected 40 years ago are now coming online within the IMPD. Next. So this is driven by, kind of the culture of fair data, right? This growing culture of getting more data accessible, publishing a paper and making your data accessible. And that's a good norm that helps us a lot. And we really believe in that as a mission. There are also more and more funding agencies that are either strongly encouraging or requiring data sets to be made public. So you can see more than half of our data sets come from the states, and within the US, there's maybe a dozen or so funding agencies that really want to see their data online. I can't say mandate because even if they're mandates, they're not really enforced, but people are complying with those statements, creating data management plans and so forth, and then passing the data on to public repositories like ours. And then most of the rest of the data are coming from different European countries. And then there's journals that are now certainly pushing harder toward open science and making the data sets public. So we highlight the AGU publications here as one source of data sets where people are using citations that can be derived from DataCite and the DOIs that we create upon ingest. And just if you look closely at this data availability statement, this will come back up, but the same data came to us at NCEI and also to Zenodo. So people are, submitting their data in different ways that they can find to make them available. Next. So some of the use cases, what are the consumers doing with the data? There's certainly a lot of scientific research. We see the different archives mentioned in papers or directly cited when possible. And that's good. We like to track those. And those are useful for us to help secure funding and kind of show our importance. But we see the data sets show up in a lot of other ways too. We both answer questions from media and provide data sets to different journalists and so forth. And we'll also just kind of see them show up. So in the top left, there's the CO2 concentration curve that published in USA Today. Along with that, we see, the National Climate Assessment had been using, and certainly the IPCC still uses data sets that we archive. So we kind of are the backbone of a lot of the climate data that go into these, major multinational assessments. And then on the right is kind of going back to that, drought.gov site where we can help visualize the data sets for people to look at, paleoclimate drought in, the 1500s, for instance, versus what you normally see when you log into that site, which would be, the last month maybe. At the top there is a web resource that shows the flow of the Colorado River for the last 600 years and different resources around that. So all those data sets are being streamed or downloaded from our archives. In education, about half of the folks that correspond with us through our survey are non-scientists, and so we have a lot of teachers and others that use these data sets in their classrooms and for various outreach purposes. And so that's a really important component of the user base that we pay attention to. Next, and I think it's yours, Carrie, again.
That's fine. Yeah. So that's our background or kind of summary of who we are, what we do. And now the next section of our talk is more about what we currently do that's fair. So a couple of these boxes we're going to dive into greater detail on in the next couple slides. And that's our Search UI, application programming interface, the past thesaurus, and the data formats. So I will just pause here to talk about the other three boxes, the paleo perspectives, metadata standards, and persistent identifiers. So in terms of metadata standards, Chris talked about this briefly, that we output our metadata in various forms that make our metadata interoperable. And this includes the NASA Global Change Master Directory keywords, ISO, and Dublin Core. In terms of persistent identifiers, we mint DOIs for all of our data sets through DataCite. We use the Registry of Research Organizations to document or to keep track of the funding agencies that have supported data collection. And ORCIDs, we track ORCIDs for all of our investigators. In terms of the paleo perspectives, as Chris mentioned, about half of the folks we correspond with or who fill out our surveys indicate that they are non-scientists. And so this has been, there's particular pain points for these users who kind of get dumped into our site. If you do a search all in our site, you'll get almost 14,000 things back. And they're unfamiliar with the jargon and the terminology that's used. So we've developed several paleo perspectives, which are kind of a more curated way of being introduced to some of our most used data sets. For example, that carbon dioxide curve for the last 800,000 years, or information about temperature of the last 2,000 years. So these tell stories. There's text and narrative and links to the underlying data sets. So then diving a little bit more into a couple of those boxes, our user interface is the point where most users come to find our data. And these are screenshots of various components of our UI. You could search a lot of different ways, including by investigator, geography, variables, or time span. And I've highlighted here in the orange box, Chris mentioned this, that we do harvest metadata from Neotoma and PANGAEA, and it's searchable here through our UI in a kind of more limited way, because we haven't harmonized all of our metadata. But there's a couple of these metadata categories that you can use to search across different repositories. For our API, not so many folks use our API. We're trying to provide more training and documentation because we sense that there is interest in the community to use the API. But right now, it's kind of a do-it-yourself effort to use the API to search and access our data. So here on the left, you can see we have a couple of different endpoints. The study search kind of replicates what our UI does. The CV term allows access to metadata about our variable controlled terminology. And then two other endpoints actually help to access data, not just metadata. So there's kind of two different workflows that people use to search and access data through our API. On the top is to use the get study search and access JSON metadata, and then from that metadata, pull out the URL of the data set and code in R or Python an actual download of the data. The other approach is the orange arrow along the bottom, and that's using the data search and data status endpoints to actually bundle and download data sets that you found. And so, as I mentioned, we have some amount of code and help for people to use our API. Specifically, Chris wrote R IMPD and some functionality in R for the ITRDB. And we also have some very simple R and Python example code for folks to do this. And we'll circle back to this in a couple of slides as we talk about kind of future initiatives of where we would like to go for FAIR. So as I mentioned, the UI is the point where most of our users are coming to search and access data. These two plots just show data access through time. On the left is the number of requests to our UI and API, which is growing through time. And the plot on the right is the number of data collections returned. So that's the results, the kind of count of the results of data collections that are returned as from people's queries. Again, much more so through the UI than the API. So I wanted to talk just a little bit about our variables controlled vocabulary, which is called the Paleo Environmental Standard Terms Thesaurus. And this is how we document the different measurements that people give us. As I mentioned, outside of our two specific tree ring-based databases, the landscape is very heterogeneous. We cover lots of different types of data. There's more than 1,200 different types of data measurements. So this was an initiative that we led in the 2015 to 2018 time frame to make a controlled vocabulary that allowed studies to be searched on their measurement and found much more easily, as well as to be reused so that you have some kind of sense if it's an apples to apples kind of combination by combining two data sets. So the way this is structured is very hierarchical, which is shown here on the left. This is just a sample of our Coral controlled vocabulary. So you can see how it's organized kind of with parent-child relationships to kind of keep it tidy and more organized. So there were several different objectives or what we were aiming for in building past. The first was to make it extensible, meaning we knew we were going to have to update this frequently as new data sets came in with new types of measurements. We needed to have ways to allow this to grow through time. The next was to make it sustainable. With so many different data types and data measurements, it was kind of a struggle to determine how specific to get the terminology, creating and keeping it at just very general terms versus drilling down into very, very specific terms that might only be used once or twice. Another challenge was keeping it connected, for which we try to use and link to existing vocabularies as much as possible. And then the last was keeping things interoperable by reusing existing standards. This is the ISO standard for thesauri, as well as using the Simple Knowledge Organization System, SKOS, structure in the Resource Description Framework, RDF. I often get asked how much the vocabulary has changed through time, how much we're adding to it each year. So this table here shows our status in 2018 when the thesaurus first came online. We had almost 2,700 terms in it and 668 links to other vocabularies. Since then, the average that's been added per year is about 50 terms to describe new data sets that have been contributed to us, and about 6 links to other vocabularies. So just to drill in just even a little bit further, I showed the hierarchical framework of past, but each one of those nodes in the hierarchy has a lot of rich metadata that's associated with it. And that's what the plot here shows on the left. You could see that the narrower and broader, that basically is defining the hierarchy. But we also have things like non-preferred terms. That's the alt label. This is an example for the term carbon. So our alt label is a capital C, the abbreviation for carbon. We have definitions and scope notes. Scope notes are kind of more to help us track like what the term is used for. It's a little bit more internal. as well as connecting individual terms to the different data types they represent or that they're used for in this case, paleolimnology and paleoceanography. And we also, as I said, track connection or linkages to other vocabularies. And these images here on the right just show other vocabularies that we've established, either exact or close matches between our terms and terms in those vocabularies. And for now, those matches are just, they're downloadable in the SCOS RDF that we provide of past. But otherwise, we're not making a ton of use of them, which we definitely could be. So I think now I pass it back to Chris.
Yeah, thanks. So while we're in the weeds, just a touch further into what these data sets actually look like. So Carrie mentioned there are two particular data sets that are kind of field specific, so that the two within the tree ring world and then kind of everything else. So this is standard tree ring data for anything that's measured having to do with the ring growth. This happens to show the actual widths of rings in a style or a format called RWL, ring width. I don't even know what the L stands for. Anyway, so this was a format developed back in the 1970s to be machine readable at the time. And one of our legacies, we still use it for all its pluses and minuses. But it's a standard of the field. And we have an advisory board for this database that, is populated by representatives from throughout the world, about 10 people maybe. And once they tell us that we need to abandon these and do something else and give us an alternative, then we'll do that. Until then, we've made the most out of these data sets. So this format, shows ring widths across each decade as labeled on the left with its sample ID. So it's readable by a couple different software libraries. The main one folks seem to use is in R. There are also a handful of Fortran programs that have been in use since the 80s that people use. So we went through all of these files programmatically and cleaned them up, found different odds and ends and errors. Uh, in that process, we really improved our QA/QC process at ingest. So we now can tell users what we expect of the data sets before they're submitted. And so that's really cut down on ingest time and made the quality of the itinerary much higher, so that we know everything coming in is now compatible with the DPLR library within R. Um, so that's kind of our standard now. And it will be easy because this is now cleaned and formatted. When a new standard comes online that is actually accepted by the community, I think there's 27 different tree ring formats out there. Uh, we can easily adopt it. Next.
Oh, sorry.
Thanks, Gary. So within the FireScar world, this is what an FHX or a fire history exchange file looks like. These also are just pretty simple text files, but a little bit more difficult to interpret for people. These were also developed in the 90s for a DOS-based program that is now you need a DOS emulator to run it. It's really difficult. But there are new tools, software tools out there that can still read these files. And so it remains the standard for tree ring FireScar data formats. So you can see it has the left side has, a big header with a bunch of information, some of which is just not populated often. And then it has all the trees listed at the bottom with this kind of matrix-like descending column orientation with different symbols for the scars and other features. When we developed the burner library in R, we needed to convert this to something that was more useful within the computer system. So we developed a three-column format where all of the individual trees are stacked up, so they can be thousands and thousands of records long. But it's a very useful format for computing, and so we're now sharing that format on the NOAA archives as well. So new data sets that come in have an FHX file plus this other format within their template. And so it's kind of a slight way to push a new data standard for folks, but we give the option, and these are now very machine readable through the, couple different pieces of software that you can use for them. Next. So then everything else goes into this NOAA template format, which we're now on version 4 of. It's quite robust. It's information rich. So on the left, you can see kind of snippets from it. It's much longer than what you're seeing on this, depending on the study and how much information was shared with us. Um, but it describes, where this data set would have come from, where you can find the particular landing page and links and the different metadata posts, like the JSON file, et cetera, et cetera. Information about the investigators. So here are the orchids that show up there for each person that submitted an orchid at the time of submission, and ways to cite the data set. So, we encourage users to cite the original paper for all the data sets, although you can cite data sets directly using those DOIs. And then as you keep going down, it describes the different past thesaurus um, types and what those data sets within or what each column represents, and then gives the actual data. So these text files can also be quite long, but because of the pound signs on the left, they're very easily read and interpreted by a machine. You could open one of these in Excel and be using the data within seconds. So quite easy. You can see on the right, there's kind of a graph of the proportion of each of these different data types and how much of them are in the version 4 of the standards. And so we're going back to those legacy data sets periodically and bringing them up to speed. Anything new comes in at version 4, obviously. But basically, after that, we up version based on use statistics that we see within our feedback, like we showed with those different, contribution numbers, but also use numbers, and then from requests. So again, we have this survey that we'll talk about on the next slide, actually, that is a place where if really have a data set that's close to your heart and you want to be able to read it into a program, you can let us know, and we can see about moving it to a version that's compatible with a different software. Next. So this slide kind of covers the kind of input we're getting from the user community within this survey. So we have a very simple, quick to fill out Google survey online. There's a shortened web link there, and the QR code should also bring you there. And it's been up since I think about 2017. We've had more than 230 respondents to it. And this is kind of what we see, the patterns that we see coming out of it, that people are looking for that pertains to different fair access. So certainly discovery, data and content, more explanation of data. Where did the data come from? How do you share it? So those kinds of concerns really come from our user group that's not in the research community as much as from the researchers probably looking for those kinds of things. Also tools and analysis, again, visualization and maps and access to analysis tools is certainly part of our user group that may not otherwise be using these kinds of tools on their own. And then data submission, more streamlined, more explanation of the contribution process. So we've done a lot of work. Actually, we revamped all of our submission guidelines recently to help with that concern. Um, and next slide. So Carrie mentioned the API searching and how it's kind of do it yourself, and with the kinds of input and feedback we've gotten from users in terms of wanting better access and quicker access to data, plus our own experience using the data sets and training people on them, we see this big gap between where the archive sits and where people are using the data. So we're kind of highlighting Python and R packages and different online tools. And there's kind of a gap in between, so especially if you have a virtual machine running or something like that, it's hard to go run our UI, download the data set, and then upload it into your script. So we're really trying to fill that gap, utilizing the API tools to make more consistent flow between the data sets and the programs that you'll use, the ecosystem of analysis software. So this is now in review at NSF to fund effort to build this. And us being kind of a cooperative institute paired with a federal agency, we have that advantage of adding funding when we can through these different government funding platforms like National Science Foundation. So we're hoping that this Paleoverse, as we call it, will get some funding and we'll be able to develop more of these tools that we already have, bits and pieces of put together so far. Next, and then Carrie, do you want to take provenance or do you want me to?
Either way, either way.
Go for it.
Okay. So another challenge that we, especially over the past several years, have noticed is what we're calling the dataset provenance challenge. So by provenance can mean a lot of different things, but here I'm kind of talking about disambiguating different copies of the same underlying data set. And there's multiple ways in which this happens. So starting up here in the upper corner with our data originator, and so these investigators might contribute data sets to multiple data centers. For example, like there's arrows here going a contribution to data center A as well as to data center B. Once a data set's within a data center, the data originator might take it and provide an update. Maybe more data is added or there was a correction. Some data was incorrect and now it's been corrected. And this yields potentially another copy of the data in data center A. We also have there's many large data compilation efforts in the community. For example, Pages 2K or Sisal for its Speleothems. Folks that are taking data from multiple data centers and building a database out of it, which they then recontribute in this example to data center A. So we have yet another copy of a data set. And the last example here we have is data center C that's mirroring a copy of data that's at data center A. So this diagram, when I made it, I'm like, this is a total mess, but it is. It currently is a total mess. We have in this example 5 different copies of a data set. Which is the one that's fit for your purpose? Are some of them superseded from others? Some might be subsets of others. Some might have some value added things that have been added to them through time. They're all a little different, and it's hard to know which one to use. So we're also trying to make some efforts towards this, tracking these data set linkages. So there's a couple different challenges here, though, in achieving this. This image here on the right is kind of what we want it to look like in the end. You have us and lots of other data centers that we overlap with. In each of the nodes is a different copy of a data set, and the colored lines kind of are describing how they're related to each other. However, this is going to require us finding the linkages. They haven't been documented always. And, that's challenging. It could be a challenge that AI or machine learning could be tossed at. Next is documenting the linkages. We've done a little bit of work using the PROV ontology, which seems to do a pretty good job describing the various sorts of linkages that we see. There are nuances to these linkages, though. For example, what is the meaning of update? Is an update a kind of this data set supersedes this other data set, or does it mean you use both of them together? Another challenge is how we provide this information to users. This is probably going to involve adding things to our searches, our UI or API to allow people to query differently. And then lastly is coordinating between all of the different data resources that have different copies of data sets. So we see this as a big and potentially, community-wide effort to try to document these linkages, um, and disambiguate and help our users use the data better. So that's the end of our slides. We have a link here to our main page and our contact information. I think if Chris, unless there's anything more you want to say, I think we could move on to questions. So thanks for your time.
Yeah, thank you, everybody.
Yeah.
Awesome. Thanks so much, Carrie and Chris. I am sure we have questions. That was fantastic and thought-provoking and lots of overlap with things that I think are totally relevant to this work. So, or to this group rather. Questions for Carrie and Chris. You can either put them in the chat or come off mute.
Hey, I can start us off. So I think, Chris, you mentioned having to run a DOS emulator for some of your software, and this is like absolutely not the first time I've heard of this being necessary to run like really important scientific software. Do you know if there's any plans to try to migrate that software into a more modern system, or is this just something you're going to keep having to work around? And I guess second part of that is like how prevalent is this, like having to find an elaborate workaround or quasi, just like a workaround to run some of the software with this kind of data?
Yeah, thanks, Andrea, for that. So what I was referring to was, yeah, software to use these fire history exchange files. And that's already been, superseded. We don't need that DOS emulator anymore, but it just was an example of how those the format of that data set was designed for a very specific purpose that we're now years beyond.
I see. Okay.
Yeah, there's a GUI program that can open those files, and then we develop that burner library in R that can use them as well, and just converts the data to a different format. But to this point, in our ingest and QC program for the other part of the tree ring archives in the ITRDB, we still use a Fortran program that seems to only get faster with the faster computing, but that period will probably end at some point if Fortran becomes something that's not, usable like DOS did. So we had a way to batch process it, but then and Ed Gilly, who's on this, could say more to it if you're curious, but the federal machines wouldn't allow us to run this program that could loop through the Fortran runs anymore. And so we're back to kind of running them individually, which is it's far more time consuming than it had been.
Great. Thank you.
Other questions? Yeah, Jessica.
This is maybe somewhat related, but I think it was with the burner, that three variable or three column format that you said you updated to versus the FHX. I think that was the other data format. How granular are your use statistics? Like, have you been tracking how many, like, whether most people are sort of adopting or moving to that burner format, or are you
That's
not,
a
or
good
do they
question.
just like download it and they get all of them at once, so you're not able to disambiguate which files researchers are actually using or users are actually using?
It's a really good question. I don't know if our tracking can be that granular. If people find a landing page and they download data, they have the option to choose that NOAA template file or the FHX file. I'm not sure if we can track which one they would prefer, but we've been pretty quiet about putting the burner standard into the NOAA templates. And so I would think at this point, the fire history community would grab those FHX files because they're set up to use those versus a secondary hoop you'd have to jump through to look at that other one, even though if you're a burner user and you're opening an FHX file in R, you're effectively running that three-column format. But I talk to users fairly often and say, they're like, oh, I have to make an FHX file. I said, no, you don't. You don't. Like, just for your own research, you really don't. Um, and you can put the data into that three-column format yourself, and Burner will read it just fine. So Yeah, we'll have to keep paying attention to that, but maybe it's the end of it, which I think some people would really welcome.
Uh, Great talk and just really exciting to see all the things you're working on over there. Just some really nice advances in different areas. I guess one specific question also on this sort of topic of formats. What about the lipid data format? That's become kind of widely used for like a sort of exchange format, but I don't, you probably looked at more closely than I have in terms of thinking about sort of an archival format. Is that of interest or are there limits that are of concern there?
Yeah. So one limitation is getting data into the lipid format. It's not necessarily always a very clean crosswalk between the metadata that we save and what lipid has. And so far, it's been mostly data sets that are being used in big compilations that have been kind of ported over into lipid. It would be kind of beyond our bandwidth to provide any data contribution that we receive in lipid format. The other issue for us is that many of our users aren't users of Python or R or the various ways that you work with lipid data sets. So we're more limited in terms of providing things in text format, and that's kind of our standard, a standard NOAA archival format. So lipid is awesome for like building big compilations, but it doesn't necessarily check the boxes in terms of like what we are required to archive and provide. Yeah.
We have a
We have a
question
question in the
from, yeah, go ahead,
Yeah,
Chris.
thanks, Natalie. Yeah, I saw that question in the chat about can users stream the data through the API or do they have to download the whole files? My approach with the API has been to use it mainly to find the metadata and then kind of convert those JSON files into more of like a standard data frame in R that we can use, and then use that to then link to the FTP directly. So, I think Python and R and probably many other programs can pull the data files right off the FTP if you're connected to the internet by just building the right link to the FTP or the WAF, I guess it's really called. But I think those endpoints within the API that had data can grab in the same way, so you can submit a GET request and get the data sets. But I actually am still learning myself and haven't played with that.
Yeah, you don't have to download files. You can just read from the WAF and store it kind of in your local memory of your computer and not actually have like a copy of the data set on your computer. That helps.
Yeah, the programs we've written in R will read the data sets into our environment, and then if you want to save them, it just writes them out. So we have read-write functions in these different tree ring based programs. I assume the others work pretty similarly.
Other questions?
Yeah, I'm
Oh, yeah.
curious about the your process for data cleaning the specialty tree ring database. Because it seems like sometimes you are copy, but sometimes you're the main database for like these different people. So can you tell me more about like, did they ask you to do that like data curation process and like do you provide the service to other users? Yeah, I'm just really interested in like what incited this big data cleaning project.
Yeah, that's a great question. We have the great fortune for the ITRDB to be kind of, the like all in caps database for tree ring width and associated measurement files. So it's really the kind of the gold standard in like the central repository versus other data sets that, have something similar somewhere else. Um, so to that end, there have been calls for a long time to clean it up and to like keep improving it. And so I actually neglected right before this talk to add a bunch of citations to that slide that were like papers published either performing cleaning themselves or providing tools that clean. So there's a very close interaction between, our crew and the global tree ring community that really helps promote that data set and keep it, kind of evolving through time and moving forward and being cleaner. So our work that kind of concluded in 2023 or four was largely helped by different users that had published papers or handed us data sets. We get emails periodically from folks that find a problem somewhere that we had missed. It got through our filters, and that's really helpful. We can get back in there and clean that up really fast. So it's an ongoing process, but it's been getting smoother over the last few years as we've really kind of cleaned things up. But yeah, that data set was, started to be assembled in the 1970s and then was handed over at the inception of the NOAA Paleo data sets in 1990. So there's a lot in there that, came from punch cards and things like that that we're still trying to track down and find.
Thank you so much. That's so cool.
We have time for maybe one more question. If there's a final burning question.
Thank you all for these questions. This has been, really interesting and fun
Yeah.
to share.
Well, thank you both, Chris and Carrie, for presenting today.
Thanks for having us. It's been great.
Yeah.
Great. And I think with that, I'll remind folks that we have an upcoming webinar next month on May 5th. I'll put the info in the chat and circulate it through the RCN Slack. And with that, thanks so much and see you next month.
Thank you.